Hi everyone, so this is sixth grade Elevate Lesson 65, continuing our work with composite figures. Yesterday, students were able to decompose figures into known shapes in order to find the area of irregular figures. Today, they're going to be continuing that work. So we're not going to spend too much time on the intro. We're just going to jump into our teacher model, which this question is very similar to our exit ticket question from the day before. And so here we have an irregular figure. There's no name for this figure that looks like an L. And so we are going to create known shapes, find the area of each of those shapes, and then get our total area. So when we are solving this question here, we've decided to break it up into these two parts, the part that's in blue and then the part that's in orange. The blue part is easy because it's already alongside a width and a length. So we have 3 and we have 7. 3 times 7 is 21. But then it gets a little bit more challenging once we get to the orange shape, just like the exit ticket from yesterday. We do have a length here, which is 3 meters. However, this piece for our width is a little bit more challenging. We know that the total width is 5. However, the blue shape accounts for 3 of those 5s. So imagine I took away 3 meters from that total, I would be left with 2 meters. Right? Because 3 plus 2 gives me 5. And so for our orange shape, we are going to multiply 3 times 2, which gives us 6. Adding that together, 21 plus 6 will give us 27 meters squared. Now, this is your model, so I would encourage you to model it in the same way that I'm modeling it, but for the purposes of this video, I am going to decompose it another way. We'll do this as our blue, and then we'll do this as our orange. So in our blue shape, easy, we have 3 and we have 5. Nice, that gives us 15. Our orange shape is now what becomes a little bit more complex because we have that our width is 3. However, our total length was 7. But since we broke it up, it's not 7 anymore. If we want to find the total length of only the orange, we have to disregard the total length for the blue, which was 3. We have to disregard it. We have to pretend like it's not there. 3 is no longer there, meaning that the length of the orange is actually 4, because 4 plus 3 gives us a total length of 7. So when we do 4 plus 3, 4 times 3, we now get 12. And so adding those together, 15 plus 12 gives us 27 meters squared. So again, just like yesterday, it does not matter how you decompose it as long as the entire shape has been accounted for. Okay? So after you are done with your model, you are going to launch students into 15 minutes of partner practice time. It's only 4 questions. And then 5 minutes on their exit ticket. Exit ticket is a lot more challenging because there are essentially 3 different parts that they're going to have to break the shape up into. Here is one way to break it up. Another way to think about breaking it up could be like this. Let me use orange. either way, it'll be 3 parts, right? So up here is shape 1. Then we have shape 2, which is the smaller square down here. And then we would have shape 3 in purple. So there's essentially 2 different ways to decompose. However, adding up all 3 of those parts will get you to a total area of 78 millimeters squared. So we want to make sure that students have 3 parts that they're adding together and that they get a final answer of 78 millimeters squared. For their sprint today, they are going to be continuing multiplying and dividing fractions. So choose the questions that you think are best aligned to their practice today.